Exoplanets come in all shapes and sizes, including some that resemble our Neptune. But just like there are no other planets in our solar system quite like Jupiter or Venus, each Neptune analog out there is unique, and scientists continue to study them in hopes of learning what they're made of, how they formed, and how they evolved. There are a few challenges to figuring out a planet's makeup from afar. First, most are extremely far away, so we can't study them directly. Instead, scientists must indirectly analyze the light passing through their atmospheres to search for certain chemical signatures. Second, some exoplanets have thick clouds that block all the light getting through, making it difficult to see the atmosphere within. Finally, many theories about exoplanet formation and evolution are still just that, theories. So when scientists make discoveries, they often have to consider multiple possible explanations. But over the past decade, new missions and improved technology have allowed astronomers to get better and better looks at distant planets and their atmospheres, and that has revealed a range of worlds that are similar to Neptune. Some are like Neptune in size and mass. Others are intermediate between Earth and Neptune, and some are Neptune-like in the way they orbit their stars. Each tells us something about what it was like when Neptune formed, and whether planets like this are common throughout the galaxy. First, let's start with the basics. Neptunian exoplanets are similar in size to Neptune or Uranus in our solar system. Neptune is about 4 times the size, or radius, of Earth and almost 17 times its mass, or weight. Neptunian exoplanets may have a mixture of interiors, though all would be rocky with heavier metals at their cores. Neptunian planets typically have hydrogen and helium-dominated atmospheres. We're also discovering mini-Neptunes, planets smaller than Neptune and bigger than Earth. No planets like these exist in our solar system. While Uranus and Neptune are mostly composed of hydrogen and helium, both also contain water, ammonia, and methane. Since these 3 chemicals are typically found frozen as ices in the cold outer solar system, Uranus and Neptune are often referred to as ice giants, though their interiors are warm enough that the ices inside them are not frozen. Researchers discovered an ice giant exoplanet 25,000 light-years away in 2014. We do not know much about its composition, what it's made of, or what elements are present in its atmosphere, but it's in a similar orbit to its star as Uranus is to our Sun. It can be hard to tell a lot about distant planets' compositions. Space telescopes like NASA's Hubble and formerly Spitzer glean information about planet atmospheres. By analyzing starlight, as starlight passes through a planet's atmosphere, atoms and molecules absorb light at certain wavelengths, blocking it from the telescope's view. The more light a planet blocks, the larger the planet appears. By analyzing the amount of light blocked by the planet at different wavelengths, called spectroscopy, researchers can determine which molecules make up the atmosphere. NASA's Transiting Exoplanet Survey satellite TESS is designed to discover planets smaller than Neptune that transit stars bright enough to enable follow-up spectroscopic observations that can provide atmospheric compositions. The challenge is that Neptunian exoplanets often have thick clouds that block any light from coming through, hiding the signature of the molecules in the atmosphere. The James Webb Space Telescope, launched in 2021, is getting our best looks yet at exoplanet atmospheres. Astronomers were elated to find clear skies on a Neptune-sized planet called HATP-11b in 2017, without clouds to block the view. They were able to identify water vapor molecules in the exoplanet's atmosphere. HATP-11b is gaseous with a rocky core, much like our own Neptune. Its atmosphere may have clouds deeper down, but the combined observations from Hubble, Spitzer, and Kepler showed that the upper region is cloud-free. This good visibility enabled scientists to detect water vapor molecules in the planet's atmosphere. HATP-11b is more than twice the size of Earth and slightly more massive, but it orbits very close to its star, completing one orbit every 2 days. Its year is longer, but its average temperature is still scorching hot. About 730 degrees Fahrenheit, about 400 degrees Celsius. That's as hot as the air in a pizza oven. Water vapor is abundant in the planet's atmosphere, making up about half as much of the atmosphere as methane. Scientists think the water vapor could have come from material left over after the planet formed, similar to the debris disk around Saturn. HATP-11b may also have formed with a massive hydrogen atmosphere, like Neptune, and lost some of it to space. Whatever the case, the discovery of water on this exoplanet raised more questions than it answered. For example, where did the water come from, and how does it coexist with so much methane? While scientists continue to work on this puzzle, others are studying a very different Neptune-like exoplanet that's much closer to home. The exoplanet known simply as B Centauri is nearly 500 light-years away and is the closest analog to Neptune that we know of. Unfortunately, the planet is too small to have been studied much with current technology. But in 2020, astronomers analyzed data collected by the European Southern Observatory and found that B Centauri is about 1.5 times the size of Neptune and at least 6 times as massive. Like HAT P11b, the planet orbits incredibly close to its star. In fact, B Centauri completes one orbit every 11 days, and its temperature reaches 572 degrees Fahrenheit, 300 degrees Celsius. That heat should cause the planet's atmosphere to glow in the infrared, which makes it detectable with powerful telescopes. Astronomers hope to soon learn more about this nearby Neptune-like world, and while they wait, they're looking for more exoplanets that share similarities with our ice giant. One way scientists classify exoplanets is by how close they orbit their stars. Hot Jupiters are massive planets that hug their stars, completing orbits in less than 3 days. Conversely, ice giants like Neptune are much farther away from their stars. They orbit in the cold outer regions where temperatures are just above absolute zero, the coldest temperature possible. But recently, astronomers have found hot, Jupiter-sized planets and sizzling super-Earths in a close embrace of their stars. Just like these, hot Neptunes should exist, but scientists have struggled to find them. In fact, only a handful of hot Neptunes have been found so far. Most of the known Neptune-sized exoplanets, like HAT P11b above, are merely warm, because they orbit farther away from their stars than those in the region where astronomers would expect to find hot Neptunes. The mysterious hot Neptune desert suggests that either such alien worlds are rare, or they were plentiful at one time, but have since been transformed. A few years ago, astronomers using Hubble found that one of the warmest known Neptunes, GJ 436b, is losing its atmosphere. That planet isn't expected to evaporate away, but hotter Neptunes might not have been so lucky. A star's intense radiation can heat an atmosphere to a point where it escapes the planet's gravitational pull, like an untethered hot air balloon. The escaping gas forms a giant cloud around the planet that dissipates into space. This might be the case for a planet called GJ 3470b, a very warm Neptune that is losing its atmosphere at a rate 100 times faster than that of GJ 436b, finding 2 evaporating. Warm Neptunes reinforces the idea that the hotter version of these usually distant worlds may be a class of planets in transition. It could be the ultimate fate of hot and very warm Neptunes is to shrink down to mini-Neptunes, planets with heavy hydrogen-dominated atmospheres that are larger than Earth but smaller than Neptune. Or they may downsize even further to become super-Earths, more massive, rocky versions of Earth. As astronomers continue to comb through data and search the skies for new exoplanets, they're sure to find more that resemble Neptune in one way or another. Studying these worlds will help us understand how Neptune formed and evolved and how planets like this populate the galaxy, and who knows, with enough searching, we may even find one that resembles our ice giant in every way. I hope you enjoyed this video. If you want to support us, please visit our website.